Okay guys, so far we have discussed p-n junction in a detailed way. Here we have a p-n junction. This is the p region, this is the n region, and this is the depletion layer. Now if p region of this p-n junction is connected to a positive terminal and n region to a negative terminal, then we say that this p-n junction is forward bias. So there is a flow of current through this junction. So electron move on this way and hole move on this way. The direction of current is from positive to negative terminal, so the current will flow in this way. The notation for the p-n junction diode, we normally represent it by this notation. This is the p region and this is the n region. Now if this p region is connected to the positive terminal and n region is connected to negative terminal, then this diode is forward biased. Forward biased. We also say that this is on, and this circuit is called short circuit. On the other hand, if we have a p-n junction diode, this is the p region and this is the n region and this is the depletion layer. If we connect it in such a way that the negative terminal is connected to the p region and the positive terminal is connected to the n region, then this diode is said to be forward biased. Forward biased. So there is no flow of current through this diode. And this, if this is a diode, then we represent it by this symbol. This is the p-n junction. So this is the p sides and this is the n side. P is also called the anode and n is also called the cathode. So here we connect the p region to negative terminal of the battery and n region to the positive terminal of the battery. Now this is forward reverse bias. So reverse bias I will represent it by RB. This is a closed circuit. This is off. We also call it off. This is a open circuit. So it means that there is no flow of current. Current is not flowing. There is no flow of current. So this circuit we can also represent it by this symbol. This is off. There is no connection between these 2 points. There is no flow of current through this region. This is the diode which is in reverse bias. So here we have the negative terminal and here we have the positive terminal. So it means that this is n region and this is p region. This is what we had discussed so far about p-n junction. Now we will start our new topic, which is called rectifier and types of rectifier. Next we have a rectifier and types of rectifier. First we will define rectifier. What is a rectifier is? It is an electrical device which convert alternating current like the AC current, I represent it by A dot C, into direct current. Which I represent by DC, D dot C, which is a symbol for the direct current. This is the definition of rectifier. And the process of conversion of alternating current AC current into direct current is called rectification. Like a device which convert AC current into DC current, we call that device as a rectifier, and the process of conversion of AC into DC is called a rectification. Now the current, the output current, like the current which are coming to our homes or houses or shops or markets, it's alternating current. It's of this type. It varies like this. This current is alternating current. Here we have the current and here we have the time. And this current is normally represented by I is equal to I naught or Im sine omega t, where Im is the maximum peak value of the current. This is the Im. If we represent the corresponding voltage, because we have V is equal to IR according to Ohm's law, so V is related to I by this relation, V is equal to IR. So V can also be written as V is equal to Vm sine omega t. So this type of behavior is also same for the voltage also. If this is the voltage, this is the voltage, input voltage, which I represent by input, yes, this is the input voltage. So, and this is the input current and this is the input voltage, which is given here by this relation. Now this is the maximum value of voltage, so we call it Vm or Vp, peak value or the maximum value of the current. But like current is coming to our houses or shops or market by this form. It's an alternating. It is positive and negative cycles. This is a half cycle, this is the full cycle. So half cycle is positive and half cycle is negative. Similarly here the half cycle is positive and half cycle is negative. But the devices we are using in our houses, like the refrigerator, the air condition, and we have the mobile, they are all operating on DC current. Like they are operating on such type of current. This is the time omega t and this is the current direction. So the current is constant. Like for the devices which I already the list of devices which I already mentioned, for that devices we need a current like this. It should be a unidirectional, otherwise we cannot charge our mobile, we cannot operate the air condition, we cannot operate the refrigerator, and we have thousands of such kind of devices which are operating on this DC current. So how to convert this alternating current, like this alternating current, to this direct current? For that we use rectifier. Now we will discuss this in detail, that how we are converting a alternating current into direct current. So rectifiers are of two types. One is half wave rectifier and the second one is full wave rectifier. There are two types of rectifier. One is called half wave rectifier and the other one is called full wave rectifier. So we start from half wave rectifier and then we will go through full wave rectifier. So first we will discuss about half wave rectifier. Now, how we can define it? It is the type of rectifier. It is the type of rectifier which convert positive half cycle of input AC signal, alternating current signal, AC signal into DC signal, DC output signal. Like in the input we supply the current as a AC, alternating current. It's an alternating current. Here we have the input current, okay, II. This I in the subscript represent the input current. This is the maximum value of current IM. After passing this current through this rectifier, suppose this is a rectifier, in the output we get only the positive half cycle while the negative half cycle were blocked. So this device allows only the positive half cycle. This is positive, this is positive, this is negative, this is negative. So positive half cycle passes through this device while negative is blocked. There is no negative half cycle. Then again positive cycle is allowed through this positive half cycle passes through this device. So it passes through device while the negative half cycle is blocked again, and then again we have positive cycle and negative cycle is blocked, and then again positive cycle and negative cycle block. So this type of device is called half wave rectifier. Now how it is working, so we will discuss the working principle of this half wave rectifier. I will draw the circuit diagram of this half wave rectifier, and then I will discuss different features of this half wave rectifier. Now suppose I will start a new from a new page. I will start from this one. Now let's suppose this is the circuit diagram of half wave rectifier. First I will draw it. Once I draw it, and then I will explain it in a detailed way. Now this is the circuit diagram. Here we are using a diode, a PN junction or diode. This is the P region of the diode and this is the N region of the diode. Now here we use a transformer. This is a transformer. I differentiate it by plotting a line. I will use a different color line. Let's suppose, yes. This is the transformer. This is the primary coil of the transformer. We call it P1 and this is P2. And this is the secondary coil, S1 and S2. Now transformer is of two types. One is called step up transformer. One is called step up transformer. And one is called step down transformer. Now, what is the difference between step up and step down transformer? This transformer convert low current or voltage to high current or voltage. This is step up transformer, and this transformer convert high current or voltage to low current or voltage. Like, let's suppose the current which are coming to our house is 220 volt. 220 volt or 50 hertz. Now, for the charging of your mobile, you need a small value voltage. Like, you need a voltage of around, let's suppose, 10 volt. Then, to reduce this high voltage to low voltage, we use a step down transformer. Step down transformer. Step down transformer. Now let's suppose the voltage coming to your home or your shops or your any living places is, let's suppose, 210 volt, and you need to operate a device for which you need a voltage of 220 volt. Then what we are doing, we are using a transformer here which is called step up transformer. So it's raise the voltage from 210 to 220 volt. Or let's suppose you have input source which is, let's suppose, 100 volt, and you need 220 volt. So for that we use a step up transformer. Now the difference, how we can differentiate the step up and step down transformer, the only difference is by counting this number of turns in the secondary coil or in the primary coil. If we need a step down transformer, then the number of turns in secondary coil will be smaller than the number of turns in the primary coil. Similarly, for step up transformer, the number of turns in the secondary coil will be higher than the number of turns in the primary coil. So here, let's suppose I am using a step down transformer. So the number of turns in secondary coil are less than the number of turns in the primary coil. So this is a step down transformer. So here we are applying the 220 volt of 50 hertz input signal to this transformer. So after passing this input source and reaching through this primary coil and reaches to this secondary coil, it's not 220 volt, it's now less. It's around, like, let's suppose 10 volt or 20 volts or 50 volts, etc. It depends on your requirement, how much voltage you are needed. Now here we have given an input signal, and the input signal is alternating current. It's like this. So here we have the input voltage Vi, and this is the maximum value of the voltage. We call it Vm or Vp. Some books they are using this notation Vm, and some books they are using another notation, call it Vp. So maximum voltage or peak voltage, it's the same meaning. And this Vi, which is equal to Vm sine omega t. This is the definition of voltage or current. Now, okay, I will stop my video here because it's almost 20 minutes. So I will proceed further from the next video. Thank you.